The first segment from 0 to 4 seconds, the object is at rest. You could say the object is not moving, it has stopped. From 4 to 8 seconds, the object is moving away from the 10-meter mark at a constant velocity in the positive direction. From 8 to 12 seconds, the object is at rest. From 12 to 14 seconds, the object is moving at a constant velocity toward the 10-meter mark. You could also say it's moving in a negative direction. From 14 to 16 seconds, the object is at rest. From 16 to 18 seconds, the object is moving at a constant velocity toward the 10-meter mark in a negative direction. Now, to calculate velocities, you begin by taking the final position, subtracting the initial position, and dividing that by the final time minus the initial time. So the first leg of our journey, we have 10 meters, and subtract its initial position of 10 meters. It traveled for 4 seconds. It began at 0 seconds, ended at 4 seconds. So that's a difference of 4 seconds. 10 meters minus 10 meters obviously gives you 0 meters. I like to put a little line through my zeros just so you know I'm making a 0. Divide that by 4 seconds. Obviously gives you 0 meters per second. For the second leg of the journey, the object's final position is 40 meters minus its initial position of 10 meters. Divide that by 8 seconds minus 4 seconds gives me 30 meters divided by 4 seconds equals 7.5 meters per second. From 8 to 12 seconds, the object ends at 40 meters, began at 40 meters. It's a duration of 12 seconds minus 8 seconds, 0 meters, divided by 4 seconds equals 0 meters per second. From 12 to 14 seconds, we have 30 meters minus 40 meters divided by 14 seconds minus 12 seconds gives us negative 10 meters divided by 2 seconds gives us a velocity of negative 5 meters per second. 14 to 16 seconds, 30 meters minus 30 meters divided by 16 seconds minus 14 seconds, 0 meters for 2 seconds gives you 0 meters per second. And the final leg of the journey, 10 meters minus 30 meters divided by 18 seconds minus 16 seconds, negative 20 meters divided by 2 seconds equals negative 10 meters per second. Next, we are going to take this information and transfer it to a velocity time graph. I put my seconds here. I put my velocity in meters per second here. I'm going to use a colored pencil to kind of make my graph stand out from the black lines on the background. The first leg of the journey had a duration of 4 seconds, and at that time the object was traveling at 0 meters per second. So here's my 0 meters line. Here's 1, 2, 3, 4 seconds. The second leg of the journey was a duration of 4 seconds, and the object traveled at 7.5 meters per second, which puts me right about here. 1, 2, 3. Picked a fine time to break. 4. 1, 2, 3, 4. All good. The third leg of the journey, the object was going at 0 meters per second, again for 4 seconds. So my line drops down to 0 meters per second. 1, 2, 3, 4. Continuing on now, I am at -5 meters per second. So my line drops down to -5 meters per second. This had a duration of 2 seconds. 1, 2. Continuing on, I'm back to 0 meters per second. This lasted 2 seconds. And now I drop to -10 meters per second. And this is a duration of 2 seconds. There are some questions that go along with this. What does it mean when there is a horizontal line on a velocity time graph? A good answer could be the object is moving at a constant velocity. What does it mean when the velocity is negative? An acceptable answer could be the object is moving in a negative direction. For example, the object returns to its starting point. And finally, what would the velocity versus time graph look like if the initial velocity was 5 meters per second in the positive direction, and then the velocity gradually decreased to 0 meters per second? This is what it would look like. I'm just going to put my 5 meters per second here. So my object starts at 5 meters per second. Its velocity decreases to 0 meters per second in the positive direction, and that would be the line.